Yesterday we started our topic on multiplying polynomials using algebra tiles, and we also in the video mentioned the area model or box model that we're going to see today and the multiple distribution that we'll also get to today. So as a reminder, polynomials are made up of multiple terms. So these are binomials because they have two pieces, so like a bicycle, they have two terms within them. So this is one binomial and this is another binomial, and we want to multiply them together. Yesterday we talked about doing that with algebra tiles and how we could do an x tile and then 3 1 tiles. And then over here we did an x tile and we did 4 minus 1 tiles. 2, 3, 4. And then we filled in all of the combinations. So this is x times x right here, gives us a big x squared. This x times this 1 here gives us an x, and then another x, and then another x, and so on. So we filled in this whole grid and counted up how many pieces we had to get our result, our product of these two binomials. And then I also mentioned how we can just take this x like we put here, and then instead of having 3 1s, we can kind of collapse those into a single piece and have a 3 here. Since all those 3 1s are the same type of thing, they're identical, we can just put them as 3 instead of 3 separate 1s. Likewise, when we're multiplying our second binomial, we can put x here, and instead of 4 negative 1s, we can just put a minus 4 here. Then, just like we did here, we're going to multiply each thing, each row, by each column. So this box here is x times x, and we get x squared. This box would be 3 for the column and x for the row, so we get 3x. This one is x for the column and negative 4 for the row, so that's negative 4x. And our bottom right box is 3 times negative 4 makes negative 12. So for our product, we have one x squared term and one constant term, but we have two x terms, so we need to combine those and collect our like terms. So we're going to end up with x squared, then we have 3x and minus 4x. Adding those, we get minus 1x, so we just put minus x, and then minus 12. So this is our product, and we would get the same thing with this little simplified area box model that we would with the full algebra tile model if we filled in all the elements here. So just to make sure we see the connection, let's go ahead and do that. So 1, 2, 3, 4. So these are each a minus 1 times an x, so these are minus x's. And these minus 4x here is the same as the minus 4x we got in our area model here. Then we have minus 1 times 1 for all of these. Minus 1 times 1. So we kind of end up, let's compare these. These are all minus 1s. So we had to shade all of those in. And then let's look at how this model compares. So if we have this top left box here corresponds to the top left box here, where we multiplied all of our x type things together. The top right box, this 3x, is right here at the top right of our tile model. It was where we multiplied this x by 1 3 times. Then our lower left, negative 4x, that's right down here. And finally, our negative 12 is down here. So these even come out in the same spots that they do within the area model. We're just taking them and drawing a lot fewer things and compressing those into individual term numbers. So this is a quicker, more efficient way of getting the same result that we had from the algebra tiles. So the guided practice, you should know how to do this one by now, so I'm going to let you try numbers 1 through 4, and then pause the video. Once you're ready to go through them, unpause it, and I'll go through them kind of quickly since we already have seen how to do this. Okay, so we're going to take our two terms, our two binomials rather, and it doesn't matter which one we put on top and on the left. I'm just going to put the top one first, so this is 2x and negative 5, and then I'm going to put the other one over here. If we reverse those and put x plus 6 on top and 2x minus 5 on the left, it would make absolutely no difference. We'd end up with the same result. So we multiply our boxes, we get 2x squared, negative 5x, 12x, and negative 30. Then we collect our like terms, so we have 2x squared, 12x, and negative 5x comes out to plus 7x total, and then minus 30. Same kind of thing on all of these, so this is 2x plus 5, 2x minus 5. This one is 3x plus 7, 5x minus 2, and then 4x plus 3. And since it says 4x plus 3 squared, remember that means 4x plus 3 times itself. So this one is also going to be 4x plus 3. Now if we go through and fill all those in, we get 4x squared, we get 10x, we get negative 10x, and we get negative 25. So when we collect our like terms, an interesting thing happens here. We have a same number of positive and negative x's, and they cancel out. So we end up with no x term within our polynomial, but we do still have a minus 25. And that's going to happen when we have the second term, the constant part of the binomial, is the opposite between the two, and the first term, the x term, is the same size. All right, so down here we have 15x squared, we have 35x, negative 6x, and negative 14. So collecting our like terms, we get 15x squared, 35x minus 6x, we end up with 29x altogether, and then minus 14. Here we have 16x squared, 12x, 12x, and 9. So here we end up with the same term for both of these because we squared this binomial, meaning that the top right and bottom left box are going to be identical. So we have 16x squared plus 24x, because we have 12x twice, plus 9. So that's what you should have gotten for those. If you were struggling with any of that, remember it's just putting each binomial in a row or a column, and then multiplying the box by whatever the intersecting column and row is. So this 4x times this 4x gives us the top left box. This 4x times this 3 gives us this box, and so on. All right, so let's go on. We've got, now we're going to compare the area model to the other way we saw yesterday, which was double distribution. So we have x plus 7 and 4x minus 2. They don't give us our little boxes, so we're going to go ahead and draw them for the area model. And since both of these are binomials, it'll be a 2 by 2 box, or set of boxes. We're going to put x plus 7, 4x, and minus 2. So we get 4x squared, we get 28x, negative 2x, and negative 14. Let's collect all those terms. We get 4x squared plus, we have 28x and minus 2x, so 26x, and then the minus 14. So that's how we can do that with the area model. Let's look at double distribution. So with that, we have x plus 7 times 4x minus 2. We're going to break that up, and since this is x times that plus 7 times that, we're going to rewrite it that way. So we have x times 4x minus 2 plus, because we have plus 7 here, plus 7 also times 4x minus 2. So we're just taking each term within the first polynomial and then setting it up to distribute over the second term. If we had more terms, we would do it the exact same way. So if this were a trinomial and this were a binomial, we would just end up with 3 distributions. So we would have triple distribution. So we can do this method, we can extend this to any number of terms. So another method you might have seen for multiplying two binomials is abbreviated as FOIL. first, outside, inside, last, where we do first, then outside, then inside, then last. Which is nice, but it's kind of restricted to binomials as far as first, outside, inside, last. If we had some bigger order polynomials, it wouldn't be quite so simple. But notice that with FOIL, the first and outside is just distributing the first term, the x, across the second binomial. So we did x times 4x and x times minus 2. Then the second part, the IL part of FOIL, the inside and last part, distributes the 7 across those same two terms. So I don't know why my pen is disappearing, but oh well. So we distribute the 7 across the same two terms, and that's what we've written out here, just as distributions rather than with all the little arrows. So let's go ahead and distribute these. So x times 4x gives us 4x squared, and x times minus 2 gives us minus 2x. Notice that those are the top left and bottom left boxes in our area model. So the area model is using this same idea of distributing the x to that whole binomial. It just puts it into boxes. Then we're going to distribute the 7 and get plus 28x minus 14 by distributing the 7 here. And we end up with the exact same 4 terms that we got from the area model. They're just written out in expression form instead of in these little boxes. But when we collect them, we still have 4x squared. We still have negative 2x and positive 28x nets us 26x, and then a minus 14. So these models, these area model, these double distribution or multiple distribution, and even the algebra tile model all give us the exact same results. They're all different ways of visualizing and thinking about the same problem. So see if you can go ahead and follow the method that we used here to fill in the next one for area model and double distributing. So when we do these on quizzes and tests, you can kind of pick the one that works best for any given problem or that makes the best sense to you. But for our practice today, please make sure that you're doing both of these things. So try them both out, see how they work, and kind of see which one feels more natural for you. So try out this question that's unnumbered here, and then numbers 13 and 14. Pause the video and try those, and then I'll go through and show you the process if you're struggling with it. All right, so our area model for this one, we're going to make our little boxes. We're going to do 6x minus 1 and 3x minus 8. That gives us 18x squared minus 3x minus 48x and plus 8. So be careful here with negative 1 multiplied by negative 8. When we multiply two negatives, we end up with a positive. So we get 8x squared minus a total of 51x plus 8. And then double distribution, we're going to put the 6x times 3x minus 8. And then we have minus 1, so we're going to put minus 1 times 3x minus 8 as well. When we do our distribution here, 6x times 3x is 18x squared. 6x times negative 8 is minus 48x. Then we distribute the minus 1 across these two terms, so we get minus 3x and plus 8. Collecting those four, the same things we had in the boxes, we're going to get this exact same result. On the next two, let's do those real quick. So we have our area model. We have x, negative 3. This one's different actually. So hopefully you figured this one out, that we have a binomial and a trinomial. So that means that one of our dimensions of our box here needs to be 3. So I'm going to go ahead and put it 3 columns and 2 rows, meaning my x minus 3 goes over here on the 2 rows, and then my trinomial is going to go across the top, x squared, 2x, and 1. So now we have x times x squared gives us x cubed, 2x times x is 2x squared, and 1 times x is just x. Here, negative 3 and x squared gives us negative 3x squared. This is negative 6x and negative 3. So now when we collect our like terms, we have only one x cubed term. Remember that we're going to write these from biggest exponent to smallest. So we want the highest degree of the variable to come first. So our next highest degree is the squareds. We have a 2x squared and a negative 3x squared. So putting those together, we get minus x squared. Going to our single power x's, we have a positive x and a negative 6x. So that's minus 5x. And then our constants, we just have 1, negative 3. For double distributing, we're going to, again, distribute these two terms across the entire second polynomial. So first, we'll do x times x squared plus 2x plus 1. Then we have minus 3 times the same thing, x squared plus 2x plus 1. When we distribute these, we end up with x cubed plus 2x squared plus x when we distribute this x here. And then we have minus 3 distributed, so that's minus 3x squared. Then minus 3 times 2x is minus 6x. And then minus 3 times 1 is minus 3. So again, we collect our like terms, so we're going to find all our x squareds and combine those up, all of our x's and combine those up, and we'll get the exact same end result. And then this one is another binomial times trinomial, so we'll draw the same kind of boxes where it's 3 wide and 2 tall. You could do 3 tall and 2 wide, it doesn't matter. I'm going to put my x and 5 over here. And then this is x cubed, 6x squared, and 18x. So top left box is x to the 4th. The next box over is x times 6x squared. That's 6x cubed, or to the 3rd power. The last box on the top row is 18x times x. That's 18x squared. Going down to our second row, we have 5x cubed. We have 30x squared. And we have 50 plus 40 is 90x. All right, so we're going to collect our like terms starting with our biggest power. So x to the 4th comes first. Now our x cubeds, we have 2 of those. We have a positive 6 and a positive 5. So that's plus 11x cubed. Then we have 18 and 30 for our x squareds. So putting those together, we have 48x squared. And then lastly, we have 90x. Doing our multiple distribution, same idea. We take our first part of the first binomial, the x, multiply that by x cubed plus 6x squared plus 18x. And then we have plus 5 times x cubed plus 6x squared plus 18x. Distributing, we get x to the 4th plus 6x cubed plus 18x squared. Then we're distributing a plus 5 across this one, so plus 5x cubed plus 30x squared and plus 90x. Again, collecting like terms, we get the exact same result that we got from the area model. So the next part is some word problem practice on these things. These are describing areas or geometric shapes. So it's really important that we draw those shapes in order to make sure we understand them correctly. So the length of a rectangular swimming pool. So we need to draw a rectangular swimming pool. So length and width, we consider width left to right typically. So we're going to consider the length of the up and down, or the height. So the swimming pool is 2x minus 1 in length and x plus 2 in width. Remember, the area of a rectangle is base times height, or in the way they specified it, length times width. So we're going to multiply these two polynomials together. We don't need to do both methods here, but I think it's still a good idea for you to practice it. I'm going to show just one method or the other on each problem. So go ahead and try to do both of them for this one, and then check in, make sure you get the right answer. If you feel comfortable with this, go ahead and work through the other three, and I'll go through those a little more quickly. So I'm going to put my x and my 2, my 2x and my minus 1. I get 2x squared, 4x, negative x, and negative 2. Collecting those, we have 2x squared plus 4x minus x, so that's 3x total, and then minus 2. So the double distribution would give us the same result. Second problem, a roof truss is in the shape of a triangle. So a truss usually looks kind of like that. It says it has a height of x feet. So that's x. And a base of 6x minus 8. Recall that the area of a triangle is the base times the height divided by 2, or 1/2 of the base times the height. And that's because a triangle is half of a parallelogram or a rectangle, where our formula is b times h. A triangle is just half of that shape. So if we took the same triangle and basically drew a counterpart, like a copy of it on top right here, we would end up with a parallelogram that has the same base and height that we have here. So our blue triangle is half of that shape, so we have half of that. Okay, so on this one, I'm going to go ahead and do double distribution. So we're doing, actually it's only single distribution, isn't it? So we have x times 6x minus 8, and then we're dividing that by 2. So if we distribute on top here, we get 6x squared minus 8x divided by 2. And then we can simplify because all three terms here, the 6x squared, the minus 8x, and the 2, are all even. So we can divide them all by 2 and get 3x squared minus 4x. And then on bottom, we end up with a 1, so we don't need to write that. And that's our answer right there. All right, next one has a problem about landscaping. I'm just erasing that so I can see it. A landscape architect is designing a rectangular garden. Okay, so let's draw a rectangular garden. The garden will be 20 feet long and 15 feet wide. Okay, so we have a width of 15 and a length of 20. I drew that shorter. It doesn't matter. It's not drawn to scale, but that'll be okay. The architect wants to put a walkway with uniform width all the way around the garden. What will be the area of the garden, including the walkway? So he wants to put a walkway around the garden. Oh, okay. So he wants, let me redraw this. So he wants a walkway outside the edges of the garden, meaning we're adding on this walkway around the outside edge, which we don't know how wide it is, but it says it has a uniform width. So let's call that width W. That's how much we've added to each side. So we've added W on all 4 sides of the shape. That means that our length is now 20 plus W on the left and W on the right, so 20 plus 2W. And our width is going to be 15 plus 2W. If we multiply those, let's go ahead and write the W's in front, and we'll use the area model for this one. So we're going to put our 2W and 15 here, and our 2W and 20 here. We get 4W squared, 30W, 40W, and that's 200 plus 100, 300. Now we collect our like terms and get 4W squared plus 70W plus 300. So that way we can plug in, if we decide to make that walkway 1 foot wide or 6 feet wide, we can just plug in that value for W and find our total area. All right, last question. Bill argues that these binomials, the product simplifies to x squared plus 20x plus 20. Explain his error. So in order to explain the error, we should probably go through the problem ourselves. And let's use the double distribution this time. So we're going to do x times x plus 19. And then we're going to do plus 1, so that was our second part of the first binomial, times x plus 19. In the first one, we get x squared plus 19x. Second one, we get plus x plus 19. Collecting our like terms, we can see that we have x squared plus 19x plus 19. So the part that's not matching up with the work that Bill did is this 19 versus the 20 that he got. So it looks like he did not correctly deal with the constants by doing 1 times 19 when distributing. All right, so this next page is going to be our practice. It's more of the same that we've been doing. So these problems are all asking you to use the area model, and then these problems are asking you to, or not specifying which method. So I would recommend that you use the area model for 1 through 8, and then double distribution for 9 through 16. So you'll get some practice with both of these methods and figure out which one you like best and which one you think you'd probably use if this came up, when this comes up on a quiz or a test. So the key for this one will be on Canvas, so you can check it there once it's posted, but I'll leave you to practice these on your own.